Hey guys, today I'm going to be making a video about friction. Friction is a force that resists relative tangential motion. In other words, it's a force that resists objects from slipping and sliding. In a frictionless world, if I push Sammy, he would keep going on and on and on along the table. But because there's a friction force that exists between the wooden table and Sammy, his motion is resisted and he eventually slows down to a stop because of the force opposite the direction of motion that is friction. There are two types of friction forces that exist. The first is the static friction force. The static friction force exists when an object is static or not in motion. And there are two key relationships that you should remember when dealing with static friction. The first is that the static friction force is less than or equal to mu, which is the coefficient of friction, times the normal force on the object. The second one is that the maximum static friction force is equal to mu, the coefficient of friction, times the normal force. This right here is the reason that there is this less than or equal to sign in the first static friction relationship. The second type of friction force that exists is the kinetic friction force. Kinetic friction forces exist when an object is in motion. And the key relationship to remember here is that this kinetic friction force is equal to mu, the coefficient of friction, times the normal force. You might be wondering why there was that less than or equal to sign in the first static friction equation we talked about. Well, here's your answer. Sammy here is static. He's not in motion on the table. I can apply a little bit of horizontal force on Sammy, right? But he's not moving because there's a certain amount of static friction force between Sammy and the table that's resisting my motion. That less than or equal to sign there is because the static friction force, because the object is in equilibrium, is only going to match the amount of force that I put in my desired direction of motion, and that force can be going against the direction of my motion. So I'm pushing this way, and the friction force pushing this way against the motion. And so essentially, as I keep pushing more and more and more, that static friction force is going to increase until I hit the maximum. And then once I exceed the maximum static friction force, the object will begin to move in my desired direction of motion with the static friction, with now the kinetic friction force pushing against the direction of motion. Now that we know a little bit about friction, let's apply some of those relationships that we learned earlier in an example problem. So, a 2 kilogram block is held against a vertical wall by a 25 Newton horizontal force. So here we have the vertical wall. It's our 2 kilogram block, and this 25 Newton force is pushing into the wall, pushing the block into the wall. What coefficient of friction is required to prevent the block from sliding? So we got to figure out the coefficient of friction between the vertical wall and the block that is required to prevent the block from sliding. To start, let's draw a free body diagram. So, from our initial drawing in the problem, we know that there's a 25 Newton force coming into the block, right? And because there's a 25 Newton force coming into the block, and the object is not moving horizontally, there must be an opposite 25 Newton normal force coming from the wall. So this is the Fn, the normal force, and this is the F, we'll call it P for F push. Now we also know that because we have a 2.0 kilogram block, that there is, and these are equal, we have a 2.0 kilogram block, so we know that there must be an mg down of 19.6 newtons. And again, because the object is not moving in the vertical direction, it's static, there must be an equal force in the vertical direction. And this force is the friction force. because it's preventing motion. So we know that the block is not in motion, it's static. So we can use one of our static friction relationships to solve for the coefficient of friction. And because our 19.6 Newton friction force must be equal and opposite to the weight of the block, which is also 19.6 Newtons, we now know that this friction force is a maximum friction force, which means we can use our maximum static friction force relationship that we learned, which is the maximum static friction force is equal to the coefficient of friction times the normal force. So now all we have to do is substitute our values for the maximum static friction force between the block and the wall and the normal force on the block and solve for mu. And from this we get that mu, our coefficient of friction, is 0.784. So the coefficient of friction required between the block and the wall to prevent the block from slipping with a 25 Newton force on it is 0.784. Thanks for watching.